Hi everyone, welcome once again to another episode of Let's Get Soroban. First of all, what we need to do is set up our environment. And before setting up our environment, if you're here and you have no knowledge about the Rust programming language, I won't advise you taking this course. What I advise you to do is to take up the Rustling course. It's more of like cloning this repo and just attempting all the different exercises in the Rustling repo. You have to clone them, the different exercises inside. Just check it out, you see. Then after you're done with that, you can then set up your Rust. You also set up your environment by installing your Rust. And also, when you're done with that, the next thing you want to do, I didn't mention the fact that if you're using Linux, Mac OS, or any Unix like OS, you can use this command to set up your environment. If you're using Windows, you can follow in here to set up your environment for Windows. If you're using any other kind of operating system, you can use this as well. And after you're done with that, you have to install the Wasm unknown target. Install it by using this command. I already have it installed already, so I can't do that again. Then you also have to have, of course, an ID. Either you use the normal VS Code or you use any other one that you feel that you're okay with. So after we're done with everything, setting up the Rust packs and attempting the task, taking up little Rustling little exercise on Rustling. If you already have knowledge on Rust, you're good to go. So the next we want to do now is to install our Stellar CLI to prepare us for the upcoming challenge ahead. So you can either use these commands in here to install your CLI, this one or this one or this one, whatever it is you want to use. I already have mine installed already. Let's check it out. You can see Stellar --version. See, I already have mine installed, so I'm good to go. After you're done installing your CLI, next you want to do is to configure your CLI for a specific network to test net. So Stellar has 3 different networks. Stellar has the test net, the feature net, and the mainnet. Mainnet is where more of like where the real money is gets, and then we have the test net for just testing of what we are doing using the testnet tokens that is being interactively given to us. So by configuring your CLI, if you're using Mac OS or you're using Linux, you can use this for, you can run this command. If you're using Windows, you're advised to use this one. So since I'm using Mac OS, I'll just use this command, copy here, go to my terminal, paste this, and automatically I've set up my environment to use testnet. Then after we're done with that, you want to configure an identity for yourself. Stellar is very, very vast about this identity of a thing. They are very particular about generating an identity. So when you use this command to generate an identity for yourself, you can see that in here there's a sub command called Alice. This is more of like you saying that you're generating generating an identity for yourself with the name Alice. If I want to use Coxie, I can use this command but replace Alex with Coxie. But I don't really care about that. But you can decide to change it and just maybe have your own specific kind of identity for yourself. So you just copy this and then generate your identity using this command. After you're done doing that, what you need to know is the fact that after you generate an identity for yourself, automatically you get a public key is being generated for you, and also the public key is being funded with testnet tokens called lumens. So let's check what we generate, the address that we generated. Let us check what we have. By using this command in here, you can be able to check your public key that will be generated for you. So if you're following along, just paste this in here and you see the public key, the identity Alice. This is the public key that's been attached to my name. So now that we're done setting up our identity, what we want to do now is to scaffold a new project so that we can deploy the code project, review the code, and then deploy the project on the testnet. Copying this command, you can see it has this subcommand called Soroban hello world. So you can try to change this name to anything. It can be seller contract init assets contract, or seller contract init anything to do word contract or DAO contract, whatever it is you want to do. But since we're going to scaffold like an hello world contract, let's do this. So this is it generated for us. Let's come here and check what was generated for us. Open. So in here we have the contract being generated for us, a template. We have the lib.ios file. Let me close this. We have the test.ios file. We have the cargo.tolman file. We have the cargo.tolman file outside of the source file. Also have our readme file. So we're going to review our code that will be generated for us, and we are also going to run the test, deploy the contract, and interact our contract. This is actually this first line, line 1. This is a compiler attribute. It tells Rust not to link the Rust standard library. That's what it's telling. No Rust standard library. The next line, line 2. This line imports necessary imports from the Soroban SDK. We're going to need all of this, so this is why it's being imported in here. The next line, line 4. This is a procedural macro in Rust. Procedural macro. It marks this following structs as a Soroban contract. Saying this, when you put this macro here, it marks this struct as a Soroban contract. Then this is a contract implementation macro. What this does in here, this macros, it implements this contract, this struct hello world contract. It implements it, and inside this implementation you can see that we only have one public function called hello world. So explaining this public function, it returns a vector of symbol. This symbol is more of like a short string. Symbol is a 32 character string. That's what, looking at it here, you can see it's a valid characters of A to Z, blah, blah. Max length is 32 characters string. So it returns a vector of string. So this environment we have here, this environment is more of like a contract. The contract environment provides access to the contract specific functionality that I want to interact with. You can see it said there that the env type provides access to the environment the contract is executing within. So you see, so this tool is more of like, okay, you are sending hello to so like someone, you're sending hello to somebody, you get. So it returns this vector of short 32 character strings. It's a reference to the env, the symbol short, which is this hello world, hello, and then this. So what it returns. This is more of like a response. So moving forward, let's review the test. So what this does, this line, this first line, this is a configuration attribute that tells Rust compiler that okay, this module should only be compiled when running a test. This is the what we will need from the Soroban SDK. This imports all the files that are in here. This one imports this one. Then this is an attribute. This attribute, it marks this following function as a test. So when it's being run in our terminal cargo test, when we run the one that's in our terminal, it just runs this as a test. So this next line, let me do this. Okay. So this next line, what it does is that it creates a default environment for the contract to run in during the test. It creates a default environment.default. It creates a default environment to run through. So after the environment being created, it registers the contract. This contract is being registered with no, hold on, okay, yeah, you register the contract. It's gonna be registered, and it registers the contract with its no ID. Just register it for you like that. And after registration, this next line, it creates a client for the contract to interact with. There's something you have to note in this place. You can see that the name of our function is called hello world. As long as our function is called hello world, when writing our test, when we register the contract, this will be called hello world. It will pass in as hello world, and for the client, hello contract, not hello world. Hello contract will pass in here too. Hello contract client. If you know a contract, it's a to do contract. It will be to do contract client. You get. So doing that, it registers the contract and it creates a client for him to interact with, passing in the contract ID in here, and yeah, a reference to the environment that was being passed into the contract. After that is being done, what is done next is that the function that's in this hello contract, which is hello function, it calls the function and it passes in the what exactly we want to. Let me put my name, taxi. It's what we're sending to, and then this accept is to check that okay, this word that is being passed in here is equals to it. So this hello word, the response in here, we're getting a response of hello, and what's being passed to this coxy. Change this to coxy is equal. That's what it's trying to do. So on running our tests, we just come here and run cargo test. Cargo test. Then 3 run. It's compiling right now. So we are done. I can see the test passed. Yeah. So the next thing we want to do is build this our contract. She's going to run a command call Stellar contracts build. Wait for it to be done. So now we're done building. Okay, something you need to note is the fact that okay, we go in the target file, you see the WASM code, WASM byte code that's been generated for us. This is it. Meaning that if we want to deploy, or when we want to deploy our contract, this is what will be deployed, the WASM byte code that will be deployed. So let's deploy our contract. Come in here, and then you see this is it. Copy here and you paste this. So you have to note the fact that okay, see this is it. Target WASM release / hello world WASM. So you have to take notes of what you named your file. If you name your file to do world, wherever it is named your file, this is what will show in here, and you have to change this to the name of what is written there. And not only that, the name of the name you use in configuring your identity. Yes, if it's Coxie, if it's Alex, whatever it is should be in here. But since we use Alice, we leave it like that. And now, but this WASM is the same with this. So now it's time to deploy. Stellar contract deploy WASM, the identity, and then to the testnet, the testnet we want to deploy to. This is it. That's been deployed. Open. Now it's time to invoke our contract. Invoke in terms of interacting with our contract, interacting with the function that has been deployed. So clear, paste this, and oh my god, I didn't remember the name of the, I shouldn't have cleared this, the name, the contracts hash that was generated. I have to deploy it again. This contract transaction hash, I will need it. Sorry, transaction ID. I will need this. So on interacting, I'll have to. Okay, not now. Come here, copy this. What's it called? Contract ID. Yes, it's called contract ID. Then come in here. We clear this one. This is our ID. what was copied in here. Paste this, the source, which is the identity Alice, and then the function you are interacting with is this function hello, this is the name of the function, and then tool, the tool, which is like the symbol or the string. This symbol is more of like a 32 strings, 32 characters symbol. This is it, it's LPC, and then press OK. Press OK. Yeah, this is it. So we're done. Congratulations.